So this is section 4. This is our first shortcut for proving triangles congruent. It is called side, side, side. That's what those 3 S's for. And here is the official postulate. It's called the side, 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 or SSS postulate. And what it states is if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So just to elaborate a little bit, you might be given 2 triangles. And what you're going to look for, let's say this one's A, B, C, this one's X, Y, Z. And let's say they told you, and let's add some congruency marks, 1, 2, 3, 1, 2, 3. So let's say they told you that triangle ABC was congruent to triangle XYZ. What you need to confirm is that AB, the first 2 letters, has the same mark as XY. And then you'd look at the BC, these 2 letters, make sure it has the same marking here. And then you can also go from beginning to end and make sure that this side had the same marking. So because all 3 sides are congruent, we could say, yes, that statement is true. And the reason why would be the side, side, side postulate. So when you're writing your proof, your last statement in the proof, if they're asking you to prove triangles congruent and you have all 3 sides that match, your reason is going to be side, side, side. Now, yesterday on the quiz, your last reason was definition of congruent triangles because we didn't know any shortcuts yet. So that was always going to be your last reason in the proof from yesterday's quiz. Now, they might also, instead of giving you the little tick marks or the little congruency marks, they might also have numbers. So they might say this one's 4, maybe this one's 3, and then 5, as long as they have the same numbers in each one of the corresponding sides. Then you could show that they're congruent. So let's try a few examples. So here is the first example. They want to know if the statement that they're giving us, is this a true statement? Is this a true congruency statement? So again, what we need to do is make sure that the letters are in the correct order. Because if the letters are messed up and the sides don't correspond and match, then they're not congruent. So let's try it. So DF, we could check this side with HJ. If I come over here, DF is right here, and here is HJ. And notice they both have 2 marks. Then I can come over here and do FG. And FG is over here with 3, and it is matching with JK. And then you could go from D to G, which is this side, and make sure it matches with the HK. And it does. So you could say, yes, this statement is good, and your reason is the side, side, side postulate.
What if the sides are not equal again?
Okay, so like on the next example. So let's say they're not equal, or they don't have the same congruency marks. So what we would do again, we're going to check. So AC and CA, well, that's the same because we would use reflexive if we were using this in a proof. So really what we're doing here is we're pulling the 2 triangles apart. So this side here, AC and AC, notice it's going to be the same side in both. So, and it has a 9 no matter where it is. So this one is true. And then we would go to the next one, CB and AD. CB is 7, and so is AD. So that side's good. But then when we go to check AB and CD, notice AB is not equal to CD. So this would not be congruent triangles. You could also say 3 is not equal to 4. This is your explanation. So these are not congruent because AB is not equal to CD or not congruent. Either way. Every side has to have the same measures when you match up the corresponding sides. So again, we're going to check to make sure all the markings match. So QP with RS. QP is here, it has 2. RS is here, it has 2. Then PT and ST has 3 and 3. And then if you check QT and RT, and they do. So you would say again, yes, you can prove them congruent by side, side, side. Now this one was taking a little long. Again, I'm going to graph each one. Let me graph JKL. I'm going to graph that in red. So I'm going to go through and graph each order pair. So order pair J is -3, -2. I'm going to label it as J. Then K is 0, -2. That's K. And now L is -3, -8. Now this one goes off because the very bottom of my grid is -7. So I'm going to put it down here. So that's L. I'm going to connect the points and make my triangle. I'm now going to graph RST in blue. So 10, 0, 10, -3, and 4, 0. I now need to check to see if they are congruent. And right now the shortcut I'm going to use is I'm going to check the lengths of each of the sides. Now for the horizontal side and the vertical side, I can just count the little squares. I don't necessarily have to do the distance formula. The only one I need to do the distance formula for are those diagonal sides, the hypotenuse. Let me go ahead and put in my points here, R, S, T. So for side RS, we can see that it's 3 because it's got 1, 2, 3 squares. RT is going to be 1, 2, 3, 4, 5, 6. So it has a length of 6. Now to find the length of ST, I need to do the distance formula. So the distance formula, again, is going to be, I'm using this order pair and this one. So I'm going to subtract the x's and square them. Subtract the y's and square them. And then I square root. So 6 squared, -3 squared, all under the radical. So 36 plus 9, get 45. Now, if it only asks you to say if they're congruent or not, we really technically don't need to break this radical down. I just need to see if the length over here of LK gets square root 45. However, if they ask you to find the length of ST, you would need to leave this in simplest radical form. So here, 3 square root 5. That's the length of ST. Now let me go do the same thing for the red triangle, the JKL. Again, you can see that this one has a length of 3. You can count the little boxes. Over here, JL has 6. And now again, I'm going to do the length of KL by using the distance formula. So I'm using these two order pairs. So 0 minus -3 squared plus -2 minus -8 squared, all under the radical. So I get 3 squared, -2 plus 8 gives me 6 squared, 9 squared plus 36, square root of 45, and then the same answer. So because all 3 sides have a corresponding side that matches, I would say yes, these 2 triangles, JKL and RST, are congruent, and the reason is the side, side, side postulate. And it wants us to explain why the bench with the diagonal support is stable while the one without the support can collapse. So notice this diagonal support here. This is creating 2 congruent triangles. And when I have 2 congruent triangles, that diagonal support makes fixed lengths. So it's not going to wobble. It's not going to change the lengths of anything. So I can say that because by the side similarity postulate, the triangles are not going to change shape, and this one would be more stable. So again, we're using side, and the diagonal turns into one of the sides. Okay, so 2 additional shortcuts coming from section 5. And this time, we're going to learn the side angle side shortcut and the hypotenuse leg. So first, we have some vocab that we need to understand. So the first vocabulary is called the included side. And that means that it's the side between the given angles. So for example, side AB here is the included side between angles A and B. If I said, what is the included side between angles A and C, you would say that that side would be side AC. If I said, what's the included side between angles B and angle C, you would say that's side BC. So it's the side in between the 2 given angles. The next word or next definition or understanding we need to have is the included angle. And that's going to be the angle where the given sides meet. So for example, if I ask you what is the angle in between 2 sides, erase here. So if I said, what is the included angle between sides AC and CB? Here's AC, here's CB. So it's really the angle that the 2 sides create. So if I said, what is the included angle using sides AB and AC? So here we go. It's the angle they create, so it would be angle A. So when we're doing the side angle side postulate, we're going to need to know what the included angle means. We can't just pick any random angle in our triangle, and we're going to see that in a minute. So here is the official postulate. It's SAS, and what this postulate says, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the other triangle, then the triangles are congruent. I'm going to give you an example of that. What's important here is that it must be the included angle, not just any random angle. All right, so let's say I give you this picture. Remember, this is that bow tie. So if I say this is A, E, B, and then C, D, and if I show this congruent to this, and this, and this, what other piece of information can I add to this to show that something else is congruent? Larry? No.
Vertical angles.
Good. All right, so I can show that this angle is congruent to this because they're vertical angles. Now that I've established that I have a side, an angle, and a side, I can use my side angle side similarity postulate to prove that these 2 triangles, triangle ABE, is congruent to DBC. So what you would do if you were writing a proof for this, you would state from the diagram that AB is congruent to BD and that EB is congruent to BC, and then also state, that would be your given, and then you would say that angle ABE is congruent to CBD by vertical angles, and then you would state the triangle similarity statement or congruence statement, and the reason would be side angle side. Let me write that down just so we can clarify. So if this were proof, you would first state all the given. So you would state that AB is congruent to DB, and you would state that CB is congruent to EB, and this is given. Then your next statement is going to be angle ABE is congruent to DBC, and this would be vertical angles theorem. And then your third statement is just what you were trying to prove, the two triangles. So ABE congruent to triangle DBC, and the reason is side angle side. So now the proofs are a lot shorter because we don't need to show all 6 things. Does that make sense? So depending on the amount of your given, it could be a little bit longer or it could be super short like this. Next slide. Now, for the next shortcut, we need to understand the parts of a right triangle. So when you have a right triangle, so we have a right angle here in our triangle, the side that's opposite the right angle is called the hypotenuse. It's always going to be the longest side of my triangle. The two sides that create the right angle are called the legs. So when we're trying to use this next shortcut, you need to be able to recognize which side is a leg and which side is a hypotenuse. So the next shortcut is called hypotenuse leg. Now, all of the other shortcuts have 3 letters. So that would mean I would be looking for 3 things. However, technically, even though this has 2 letters, this only works for right triangles. So really, you're first confirming that you have a right triangle, then you're going to look for the hypotenuse and the leg to see if they're congruent. So what this theorem states is if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So in order for you to use this one, it must be a right triangle. So this is the one that people tend to forget. So what I would do is anytime you see you have a right triangle, I would see if this works. Now, don't automatically assume that it's a right triangle. It's going to be this. It could be one of the other shortcuts. It could end up being side, side, side. Could be side, angle, side. It all depends on what's given to us. So let's go ahead and let me draw an example. So let's say they're side by side here. And let's say we have a right angle. And let's say that side is marked on both. Can I use hypotenuse leg for this? Okay, let me add some letters here. So A, B, C, D. So sides A and B, AB are congruent, and BD are congruent, right? It's congruent to BD. What sides are those of the right triangle? Is that a leg or is that a hypotenuse? That's the hypotenuse. Now, do I have a leg that's congruent? Yes, I do, right? It's the one that they share. It's this guy. So if you were writing a proof, this first statement would be given. You would also state that you have a right angle here, or you could say that triangle ABC and triangle DBC are right triangles. And then you would say that BC is congruent to BC by your reflexive property, which is your leg. So then you can say that triangle ABC is congruent to triangle DBC by HL, hypotenuse leg. So 1, 2, 3, 4. Try examples. So in my first example, can I prove that these two triangles, and what I'm referring to is this one right here, and this one over here. Do I have enough information in my picture to show that that red triangle is congruent to the blue one?
Yes.
Okay, so what do we know is congruent? We have an angle, right? Angle here is congruent to this one. We also have a side. What other piece of information can we pull off of this picture? What other piece is congruent? Valeria? The line they share. Now, so this would be S. Have we learned a similarity or shortcut for ASS or SSA? Have we learned that yet? No, right? Now, just because this spells a bad word doesn't mean that it doesn't work. It's just there is no such shortcut as ASS or SSA. So these could not be congruent. We do not have enough information. Okay, now if it were the included angle, if the angle were down here that was given to us, then we could use side angle side. This angle that's given to us in the picture is not the included angle, so I can't show that these triangles are congruent. Let's try the next one. I just did the proof of this. Can I prove that these two triangles, and again, if you want to think of it as this side is red, this triangle is the blue, can I show that those two triangles are congruent? Yes. Okay, and I would be using my hypotenuse leg, because again, the middle side here that they share is the leg, and then the hypotenuses were given to us. And I do have a right angle, making sure that these are right triangles. So that's yes. Hypotenuse leg. Let's try the next one. Can I show that these two triangles are congruent? Now I do have some vertical angles here, right? But do I have a similarity postulate yet that says side and then an angle and then an angle yet? No, I don't. So these are not congruent. And also, notice, look at this mark. This one has 2, this one has 1. I don't even have that pair that's congruent. So really the only congruency here is the vertical angle and the side. And that's not enough information. What about the next one? I've got some sides marked here. And then I've got 2 angles up here. Is there another piece that I can show is congruent? That side in the middle again, right? Reflexive. So now I have side, angle, side. So I can say yes, and my reason is side, angle, side. The next one, can I show that these two triangles are congruent? Did I learn an angle, angle, angle?
Nope.
Nope. So these are not congruent. Now, remember, we have side, 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 but there is no angle, angle, angle shortcut. Because watch, if I were to draw you an equilateral triangle, let's say they're all 6, let's see, let me do 60. So 60, 60, 60, that would be equilateral. I could put congruency marks. And then let's say I tell you that they're all 4. Then I draw another larger one that's also equilateral, but these sides, say, are 8. Notice they are not exactly the same size. They are the same shape. However, the sides are not congruent. So this is why I could have 2 triangles with the same angle measures, but they would not be congruent. So this is why there's no angle, angle, angle shortcut. All right, so it wants to know, is there enough given information to prove the triangle's congruent? So let me go ahead and this is ABE. So ABE is right here. And then CBD. So then this one. So see how they sort of have an overlap piece there? All right, So is there enough information? So I don't know if it'll help you. Let's pull them apart. Maybe that'll be easier to see. So if I draw, and let's see, maybe I can do it in red to show you. And I don't want highlight, I want the pencil. So ABE. And then I'm going to draw the blue one. And then BCD. So notice on the sides here, I got these two sides congruent. And then, let's see what else I have. So then on A, that side is congruent to that side. Now, can I show another piece to get these congruent? The way that we're going to do that, also notice up here, this little piece, so like this was split here, and then over here. We can show that this piece right here, by the reflexive property, when I add it, if I were writing a proof, I would have to show like the angle addition postulate and show that this piece plus this piece is the same thing as this piece plus this piece. So I get a reflexive angle in here, and then I can show that the two triangles are congruent by side angle side. So I would be able to show that these are congruent. And we're going to be walking through different proofs like this, but we would have a reflexive angle in there. All right, next one. It says, is there enough information to prove the triangles are congruent? If so, state the postulate or theorem. So they want to know if FGH, so this one here, if it's congruent to HJK. So notice I have a right triangle on both. So that might be a clue that, hey, wait a minute, I might be able to use hypotenuse leg. Notice the sides across from the right angle have congruency marks. So those are my hypotenuses. They're congruent. And then notice I also have the legs marked. So yes, we can show that these are congruent, and it would be hypotenuse leg. Now, they don't have to be sitting like the same way, as long as you can show a leg and a leg congruent and a hypotenuse and a hypotenuse, and especially if it's a right triangle, then you can use hypotenuse leg. And then the last one, again, we're going to practice side angle side. So let's add in the congruency marks. So they're telling me that ST is congruent to YZ, and that RS is congruent to YZ, XY. They want to know, is there enough to prove that they're congruent? So what would we have to show is congruent in order to prove these by side angle side? Beautiful. So you would have had to somehow establish that angle S is congruent to angle Y. And you can't pick any random angle. It's got to be the included angle, or the angle that is made by the two sides that you have are congruent. Now, what if I ask you to prove these with side, side, side? What would you have had to show? Beautiful. That RT was congruent to XZ, and then you would use side, side, side. So now, when you're learning these individually, it's easy because you know what you're looking for. But then when we get to the end of the chapter and it says, prove the triangles congruent, or what would you use, then it gets a little bit more complicated, because then now you have to go through all of the shortcuts we've learned and figure out which one to use. Usually the side, side, side is most obvious because you're just looking for sides. However, we are going to learn some new ones with angles coming up tomorrow. So for now, this is it for your third shortcut. So we've learned side, 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 hypotenuse leg, and side angle side. So now you can complete that whole homework packet for 4-4 and 4-5. We'll go over it tomorrow. We'll also do the warm-ups for 4-4 and 4-5. And then we're going to look at the next section.